Assalamualaikum and hi everyone. Today we are going to explain to you a paper about an accurate and precise in situ determination of beryllium contents in beryllium minerals using ablation spot size of 13 micrometer by LAICP-MS. This video is presented by my friend Nur Syafiqah binti Asmuni and myself, Nur Hanis Atikah binti Muhammad Nawi. Introduction. What is beryllium? Beryllium is an alkaline earth metal. It usually used in making alloys, nuclear, X-ray window, and aerospace industries. What is LAICP-MS? Laser ablation inductively coupled plasma spectrometry is an analytical method used to analyze solid materials and technical products at trace and ultra-trace level. It uses a laser to ablate tiny spots, then ionize the material in a plasma and separates the ions by mass to detect them. The importance of analyzing the analyte from the sample. Beryllium is a critical metal. Its accurate in situ analysis is challenging. Analyzing it in analyte form can reduce the influence of changes during the measurement, which can minimize the inaccuracy in the reading. Analyzing beryllium is also important because have health and safety implications, such as berylliosis. Besides, the analysis of it can help in the uses of industrial and scientific research and economic value. Why this spectroscopic method is chosen compared with other methods? Okay, let us compare between the LAICP-MS and the traditional wet digestion method. LAICP-MS require a small size of sample, while wet digestion method require big size of sample. LAICP-MS have low requirement of homogeneity, while wet digestion method is vice versa. Besides, LAICP-MS produce a rapid analysis and accurately analyze major elements in minerals, while on the other hand, wet digestion method produces slower analysis and destructive, which can be crucial if we only have a small amount of sample.
LAICP-MS produce spectra in the form of mass spectrum, which are presented as time-resolved analysis signals. The presence of beryllium is confirmed by the 9 beryllium isotope signal peak. The mineral phase and check for inclusions can be determined by monitoring other isotopes. A smooth and steady signal plateau during the ablation period indicates a homogeneous distribution of beryllium within the mineral and stable ablation. Fluctuation and spikes indicate mineral inclusion of fracture. The signal measured before the laser starts provide the baseline noise, which are essential for determining the limit of detections. From the spectra measured, the qualitative analysis can be achieved by the presence of the 9 beryllium isotope signal peak, which confirms the existence of beryllium. The signal peaks of other 58 isotopes monitored in the study helps to identify the mineral phase and check for inclusion of other elements. The consistency of signal patterns between the replicates indicate homogeneity or heterogeneity within the sample grain. For quantitative analysis, standard reference materials such as NIST 610 and 612 were used as external calibration to compensate for sensitivity drift. The concentration of beryllium is calculated by comparing the sample signal intensity to the external standards. Internal standardization such as 29 silica is used to correct the variations in the ablation yields. Relative fractionation index (RFI) measure the matrix effect and the fractionation effect between the reference material and the samples. Some of the advantages of LAICP-MS technique is it provides in situ, real-time and rapid analysis. It allows for simultaneous determination of multiple elements and provide the chemical composition of micro areas rather than the entire particle. Next, LAICPMS also provide high spatial resolution, which allow the use of small ablation spot size. It is also able to analyze tiny materials or species with complex inclusions and bands. However, the limitations associated with this technique include fractionation and matrix effect. The reduction of ablation spot size will increase the element fractionation effects and causes the element to be ablated and transported inconsistently. Small ablation spot size will also lead to less sample ablation, which causes lower sensitivity and higher uncertainty in the results. Thus, some improvements were done to minimize the limitation of this study by using parameter optimization and the use of suitable reference material. The researchers in this study has established two potential barrel reference materials such as barrel 3 and barrel 4.2 to improve the accuracy of the results. This will substantially reduce the matrix effect rather than using synthetic glass. Moving on to the technique performance details. This technique acquires high accuracy by using suitable reference material and optimizing the instrument settings. The finding of this study fell within 5% error range of the values derived. The precision of this technique is affected by the total amount of ablation. The use of smaller spots will typically result in lower precision. This increase in ablation time will allow a more stable signal and enhance data precision. For detection limit, small ablation spot size will increase the detection limit and reduce precision, especially for the trace level of beryllium. The sensitivity of this technique is exponentially related to the size of the ablation spot. The study compensates for the small spot size by optimizing the ICPMS tuning using NIST 610 to ensure high signal output of the results. LAICPMS technique was proved to be robust for a variety of chemical groups of beryllium minerals. This is because this method has successfully determining the beryllium level in other common beryllium minerals such as phosphates, oxides, and silicates. This high-resolution mass spectrometer also offers high selectivity for beryllium by monitoring 58 distinct isotopes simultaneously, even in complex mineral matrices.
The first conclusion that we reach is the determination of accurate and precise in situ of beryllium contents can be done using LAICPMS. The second one is the analysis of rare materials such as beryllium should be improved from time to time so that it can be used safely in many ways that can give us benefits. Here are our references. That's all from us. Thank you.